So, who remembers what a vertical asymptote is? Anyone? Yeah? The vertical line where you can't really cross, it's where the denominator makes it equal to 0. Alright, horizontal asymptote. It's like a horizontal imaginary line. When that limit goes, as x goes into infinity, you hit a value. So your end behavior is actually going towards some value, not going to infinity or positive infinity, infinity or negative infinity. When we discovered these two, A and B, what did you get your vertical asymptote to be? X equals 3. So you got x equals 3 here. And your horizontal asymptote? Y equals 1. How about over here for g of x? What did you get your horizontal, vertical? None. So no vertical. And what about your horizontal? 2. Y equals 2. Now, just to see if we can predict the future a little bit, can you guys see anywhere on B where we could possibly have gotten 2? Can you see a number in there? Where something could have made 2? 8 divided by 4. That could have possibly gotten us 2, right? 8 divided by 4. Do you see over here where we could have possibly gotten that 1? 1 divided by 1. See in front of these x's, there's a 1 in front of both of them. That's actually going to be how we do find some horizontal asymptotes. How is this x equals 3 again? Yeah, right there. 3 minus 3 is 0, so you said that new denominator equals 0. How about this one? Why didn't that one get a vertical? Does the bottom ever equal 0 then? No, because if you think about it, I put in a negative number. I put a negative 2. That's going to become positive, right? Anything I put in there negative is going to become positive. And if I add 1 to it, it's always going to be even more positive. So we do not have any vertical asymptotes there. Okay, so what is a cheap and easy way to find vertical asymptotes? Besides setting the limit as x goes to some number, what is the easy way? Awesome. We're going to set that domain equal to 0. Set the domain equal to 0. Oh, denominator. Why do I keep saying that? I saw the D and just went with it. The denominator equal to 0. And I'm going to add in a little like caret here, and I'm going to say the reduced denominator. And what I mean by that is if you have a rational function and you can simplify it by like factoring and canceling things out, you should probably do that. Okay, so just a side note, little asterisk star, you should reduce rationals now. What was one way that we just kind of talked about how we could find a horizontal asymptote? Yeah, we divided the coefficients. So the way that you're going to do this is we're going to compare the powers of the leading terms. Now remember, the leading terms have to be the highest degree. So the one that we discovered from that last example was, let's say we have some polynomial, and I'm just going to label it like this. X to the n times a to the n is that leading coefficient plus dot dot dot, all the way till we get to the end. And then let's label our denominator, just to use different letters. B to the m, x to the m, plus dot dot dot, all the way to B. Okay, so just use letters so we can kind of have a base for later. Okay, so that's polynomial on top, polynomial on bottom. If this n power, so we're comparing powers, if it's less than your power on the denominator, the m, okay, so if it's less than, your horizontal asymptote, and I'm just going to abbreviate that with HA, always going to be y is equal to 0. Now, this is the one that we saw last time. If n equals m, so if they're the same power, this is what you guys got last time, your horizontal asymptote is going to be y is equal to the coefficient of the leading term, an, over b sub m. You just divide the two. And what's the last thing that could possibly happen? Yeah, the n could be greater than, so the top is bigger. That implies that you have no horizontal asymptote. So when that happens, you will have no horizontal asymptote. All right, the next thing that we're going to do in order to complete the next section is we're going to find some intercepts. When we have rational functions, when we have any normal function, how do we find our y-intercept? So there was 0. What do we make 0? Do we make the x 0 to find the y, or do we make the y 0 to find the y? We make the x into 0. So if we want to find the y-intercept, we normally do f of 0, correct? F of 0? Now, just a quick hint. If our polynomial has a bunch of x's on top and a bunch of x's on the bottom, the only thing without x's are going to be these last two terms, aren't they? Right? So our y-intercept is typically always going to equal our a sub 0 over our b sub 0. All right, how about that x-intercept? What do we make 0 with x-intercept? The y. So we're going to make our y equal to 0. So if I set this guy equal to 0, what would be my first step in order to solve it for 0? Some people are doing this with their hand. I would multiply the denominator on both sides, wouldn't I? Okay, so let's just make a really quick example. 0 equals x plus 1 over x plus 2. My first step would be to multiply by x plus 2, wouldn't it? Once I multiply 0 times x plus 2, what happens? Doesn't it just go away? So do I have to even do that step? No. So really what I'm going to do is I'm going to set 0 equal to the numerator and solve for that. I don't have to worry about my denominator when I'm finding my x-intercepts. Okay? And the reason for that is because once I do that multiplication step, it just goes away anyway. Okay, so our next few examples, what we are going to do is we are going to learn how to graph rational expressions without using our calculator to look at them. We're going to learn how to graph them. Okay? They're not too hard. Because most of what we're doing is going to be a rough sketch. All right, so when we graph rational expressions, we're always going to follow these steps. Our first is to find the domain, find and sketch any asymptotes, find and plot the x and y intercepts, if any. This is the most confusing, but it's not too difficult once we get a hang of it. Find and plot at least one point in our test intervals, and I'll make more clear what those test intervals are a little later, but they're determined by any x-intercepts and any vertical asymptotes. They're not too bad there. All right, so let's start off. Domain. I want you to turn to your partner and tell them what the domain is right now. Of this function. And here's some all real numbers getting blurt it out. Can it not be something else? It cannot be -3. Okay. Anything that has a polynomial usually is all real numbers, except if it's in the denominator. And at that point, you're going to have to take away anything that makes it equal to 0. And in that case, it is -3. Okay, our next step, find and sketch any asymptotes. So, vertical asymptote. What is our vertical asymptote? X equals, awesome, X equals 3. Our vertical asymptote is X equals 3, so I'm going to come over here and I'm going to sketch it. 1, -3. 1, 2, 3, 1, 2, 3. So when we sketch vertical asymptotes, we make them with a dotted line here, imaginary. So when we dot something, it usually means that it's not actually there. We do it with the dotted line, or dashed line if you want to say dash. All right, horizontal asymptote. Okay, horizontal asymptote, we follow that pattern up above. We have to see which one has the better power. Which power, what is the power of the top, the numerator? 0. 0. There is no x value, so the top power is 0. Okay, what is the power of the bottom? 1. So n is equal to 0, m is equal to 1. So 0 is obviously less than 1, right? Because we only count the variables with powers, not the coefficient.
Wait, what's n?
N is the power of the top, it's the numerator. M is the power of the denominator. I don't know why they don't use D, don't ask. Maybe denominator with M then. I have no idea.
How do you get 0?
Okay, there is no x, so it technically would be 6x to the 0. But anything to the 0 power is 1. So it'd be like 6 times 1. So if you have no x, the power is
the top.
N is the power of the top.
N.
N is the power of the top. M is the power of the bottom, which would be 1, because x is the first.
Okay. You said some of the 0 equals 1, so why isn't n?
This end?
Yeah.
Okay. Because I'm looking for the power, not the actual number coefficient. Just the power. Okay. So if I get zeros less than 1, which one am I following? The top, middle, bottom? The top. So my horizontal asymptote is y is equal to 0. So I'm going to go over here and I am going to graph y is equal to 0 by doing a dotted line right on my x-axis. Okay. So I now have graphed my horizontal line. I have now graphed my vertical asymptote. All right. My next step, find and plot the x and y intercepts if we have any. Okay, let's do x-intercept first. Sound good to you? All right, x-intercept. X-intercept, we just said was when we set the numerator, the numerator equal to 0, right? So, top is 6. 6 equals 0. Does that ever happen?
No.
No, so do we have an x-intercept?
No.
We do not have any, so none. Except y-intercept we say is when we plug in 0 for our x's, so we do f of 0 equals 6 over 0 plus 3, which equals 2. So we can come over here, and I can go up 2, and I can plot that point as part of my graph. Okay? Yep. The horizontal asymptote is found by finding the power of the top, which is 0, and the power of the bottom, which is 1. And then we go up to compare our chart. Since the top was smaller than the bottom, we always have a horizontal of y equals 0. Okay. Later on, we'll get to different cases. Okay. Okay. What are we? Oh, okay. So, do you see how your graph is kind of split up into different areas? Like you made a little cross here with the pink. See that? Okay. So, rational functions always look kind of the same. They always, remember you guys graphed, oh, there it is. Remember you guys graphed this guy? Usually look like that, okay? They kind of want to go towards those asymptotes. They always do. So we're going to do the cheap and easy way out of this, and we are going to graph it by knowing that we want to go towards asymptotes. This right-hand case, see how we have a point in this upper area? Okay. Our graph does not want to cross over this asymptote, this horizontal asymptote, and it does not want to cross over the vertical asymptote, but it wants to get close to it. Since we know we're already in the top area, we can just make a line towards our vertical asymptote and towards our horizontal asymptote, and we have it covered. Okay? I'm not too concerned about any other point in there as long as you have found a point in that area. Just one single point in that area. Sound good? Have we found a point in the left side? No. So on the left side, we have to find out if it's on the bottom area or if it's on the top area. Okay? So how do you think we'll find a point in that area? Plug in a number. What number would you like to plug in? Now, I would always suggest plugging in the easiest number you can think of. Negative 4? Okay, let's try negative 4. F of negative 4 equals 6 over negative 4 plus 3, which would be 6 over negative 1, which gets us negative 6. So I'm going to come over here to negative 4 and go down to negative 6. 1, 2, 3, 4, 5, 6. Notice how accurate that was? You guys notice how accurate that was? I just kind of went lower, and that's fine. Okay? Now, statement. The graph is going to be up here at all? No. Is it going to go down here? Can you guys go with your hands kind of what it will look like? Yeah, like that. All right. So we're going to go up, and we're going to hit it, and we're going to head towards each asymptote. And now we have it graphed. Okay, so of the ones that you're going to graph, these are kind of the easiest versions, where they just have the two going on. And it does help to make sound effects. Okay. There are other times when we have a little bit more going on. So on this top here, remember I said we should check and see if we can simplify it first, right? So the way to check and see if we can simplify it is you factor it. So f of x equals x plus 1 on the top. Can anybody factor the bottom for me?
X minus 2 plus 2.
There you go. X minus 2, x plus 2. Okay, does anything cancel there?
No.
No, okay. So we're not too worried about anything going away, but we always need to check that before we begin. Hint, like the last one we do, we will cancel out. So. Okay, so domain. Factoring in helps us find the domain a little bit easier, right? So again, I want you guys to look at somebody next to you and tell them what the domain of this function is. I love when you guys do that. It sounds like this big blur of noise. All right, I heard all real number except for x is not equal to, and x is not equal. Everybody agree with me?
Yes, sure.
Okay. It's always going to be all real numbers, except where the denominator equals 0. And that happens at 2 and negative 2. Yeah. The top will always give us everything. The bottom is where we take away things, so we can't have a 0 on bottom. Okay. Vertical asymptotes. Horizontal asymptotes. I want you to write down what you think are the vertical asymptotes right now. Stab in the dark at what that horizontal asymptote is. Go right ahead. I want you quickly to write down what you think is that vertical asymptote. We actually kind of have them written down already, right? Good. So vertical asymptote, I'm seeing a lot of x equals 2, and x equals -2. Find those vertical asymptotes, I want you to go and graph them. Horizontal asymptote. What? 1. What's the degree of the bottom? 2. So that means since the top is smaller than the bottom, our asymptote is 0. So y equals 0 again is our horizontal asymptote. All right. Okay. We have what? Sounds good. All right. We have our horizontal vertical asymptote. Without looking back, what is the next thing we want to find? Intercept. So we are going to find our. How do you find y-intercept? Yeah, find that f is 0, set that x equals to 0, and that gets us. So 0 on the top, right? 0 on the bottom. 1 over. So it'd be 0 plus 1 over 0 minus 4, which gets us -1/4. That's a really ugly number, but we're going to graph it anyway. That's about there. Sure-ish. Okay. X-intercepts. How do you find x-intercept? So 0 for y, we said what specifically equals 0? The numerator, thank you. So we said our numerator equals to 0, our x plus 1 is equal to 0. So x equals -1. So I go over here and I plot that value at -0. Here we go. -1. Ooh, okay, so I got some stuff going on. Now, in this case, how many sections do I have? Last time I had 2 sections because I only had 1 thing splitting it. Now I have 2 things splitting. Sections do I have? I have 3 sections. I have 1 here on the left. This section over here on the left. Over here. I have a section down the middle. I have a section on the right-hand side. The middle function is always going to be funky looking. All right? Just so you know, the middle function looks funky. It can either usually look kind of like a cubic function and kind of look like that chair, or it can look like a quadratic function and just go up, up. Okay? So it's going to look funky. The outside functions, the right and left, will always look like the bloop or the bloop, bloop, or like that. Okay? They'll always look like those little like C thingies. So let's get done with this middle function first, and then we'll have you see if you can do the outside part. So the middle function I said is either always going to look kind of like a cubic, where it looks kind of like a chair, or it's going to look like a quadratic, like a smiley face or a frowny face. Right now we have 2 points inside of that area, don't we? Okay. Right now it looks like on this left-hand side of this area, it looks like it's going like decreasing or going towards that -2 line, doesn't it? Let's see what happens when we're on the other side. Point to choose on the other side of this middle 0 point. 1. So let's see what happens when we put in f of 1. So f of 1 is equal to 1 plus 1 over 1 squared minus 4. That gets us 2 over -3. So -2/3. And that is less than our -1/4 value, so somewhere in there, right? Okay, so does it look more like a chair or quadratic? A chair. So take your value on the left-hand side at the -1 value and make it go up towards your asymptote, to your 0 and towards your 1, kind of like a chair, and then go down towards your other asymptote, making it look kind of like that chair. Yeah?
How does it get through
the horizontal asymptote? Horizontal asymptotes can be crossed as long as you're very, very close to 0, but as you go out towards infinity, they won't be crossed. And that's the definition of it. As we go out towards infinity, it's heading toward the value. But when you're close in the middle, it can't. I know it's weird. Yeah?
Where did you use the f of 1? Where?
F of 1 is right here, and I used it because I wanted to know if it made a cubic or a quadratic. Okay? Yeah?
Have you ever crossed vertical asymptotes?
No, never, because it makes that denominator 0. Alright? So I want you guys to try to figure out what you're doing on this left-hand side and this right-hand side, but let's all agree before we begin on what values we're going to test. So what value would you guys like to test on the right-hand side? 3. So we're find f of 3. What about the left-hand side? Negative 3. Okay, so I want you guys to test f of 3 and f of negative 3. Confirm with the people next to you that you got the right numbers when you put in 3 and negative 3. And then I want to see if you guys can graph it.
Yes.
So remember, we're concerned if we're above that horizontal asymptote or below that horizontal asymptote. As long as we're semi-close to the exact value, I'm good. So once you find those values of f of 3 and f of negative 3, see if you can graph this. Okay, so that we're on the same page. What did everybody get for f of 3? 4/5? Anybody else confirm? 4/5? How about f of negative 3? Negative 2 or 5 or negative 2/5? Okay, so f of 3 is 4/5. That would be about here-ish. Sound good? All right, I'll put a 1 there just to make it look right. And then negative 3 is at negative 2/5. It's about here. So what was above the line was below the line. So this guy on the right, what do you think it's going to look like with your hand? Yeah, the ones that are having their hand up, got it. All right, it'll look like this. Ooh, I didn't even go to that point. That's better. And the one on the bottom? Yeah, there you go. Goes like that. All right, how comfortable are we with this? How comfortable? Very little, medium?
Medium high.
Medium high?
Medium good there.
Thumbs way down, thumbs kind of up.
I was doing that.
All right, this first one here. I'm going to get you started, but I'm going to have you guys do quite a bit of it. What is the thing that we say that we should probably do to it first? Factor it. Go ahead and factor it. The trick on the bottom is to take out that 2 first. Then it makes it a little bit easier to see.
Shoot. Yes. No.
All right, after you factored it, what's our step? Find the domain. All right, so with your group, I want you guys to find the domain after you have it factored.
Oh, I got that too.
No, you can leave it like that, or you can refer to either.
Hey.
No, it would just be 2. So again, confirm with your group what you got. No, it would actually have that. All right, so once you have found the domain with the people next to you, find those vertical asymptotes and make sure that the person next to you is on the same page as you are. Do not leave your friends Yep, but two. That's only for this next one. Right, so I think that was 2. Don't leave your friends in the dust, put something up there. Okay, so the top is 2 and the bottom is 2, right? So your horizontal asymptote is going to be the coefficients in front. All right, so horizontal asymptote's a little new on this case. On this horizontal asymptote, what's the degree of the top? What's the degree of the bottom? They equal, so what does that mean? Yeah, so our asymptote is the number in front of the top, the coefficient, 1, divided by the number in front of the leading degree, the coefficient, 2. So our horizontal asymptote is no longer 0 in this case, it is actually 1/2. So when we draw it, we would have that dotted line right at the 1/2. A little bit different. Okay, so the rule is if we have the same degree on top and bottom, then our asymptote is no longer y equals 0 with the leading coefficient, so 1/2. Vertical asymptotes where the denominator equals 0. So you should have 2 of them. You can just wash it off. Graph was right. You upside down. Okay, I got 3 and negative. Actually, there's 0, 0. Actually, I think again, guys, don't leave the people around your table in the dust. Go ahead and check out with them. See if everybody's on the same page. Nerd. What the fuck? Make sure the person next to you is on that same page. Why? I'm gonna wire. Are you okay?
Oh. I don't know what doing this right. Stuff. What is it? And on the top, we like
About 0. I think I put 0, didn't you? Oh, I see. When should be both.
that. I sit after that. This is right.
So you got 23 and 3, so you know what I think that's a negative give your wire.
Just plug in 0 to 2. Yeah. Oh, I was doing that. I was like, yeah. Yeah.
Would 3 over 2 be above?
Yeah. Yeah, it's so 3 over 2 is 1.5. They'll be like,
Look at this.
So you want to go
Okay.
this on the board?
Okay.
Are we supposed to like be
You know how to show you where just answer it? Or class
Go on here.
Oh,
one? Oh wait. So you're gonna get it.
1, 2. 1, 2. Plug in something.
Okay, you know, that makes no sense. There's no channel like that. What? What are you talking about?
What do you now?
This is our
So perhaps that's a graph look at that. How does that graph look? Now you know what you're doing that graph. Right? That's 2 points on each side. Alright, so Abby's so nicely putting up what she has so far, the points she has found, the values, and I think most of you have gotten to this point as well. Okay, so she has found all her asymptotes, her vertical asymptotes, and she has gotten a point at -4 and at 3, so she knows the graph on the left and the right hand side look like this. She only knows that we have a y-intercept at 3 over 2, and she doesn't have an idea of what that middle looks like yet, right? How can we find out what that middle looks like? Find out what f1 is and f of -1. So we're going to find out what f of 1 and what f of -1 are, because those are kind of on the other side, but still in between our asymptotes, right? Okay, so they're in between, but still on each side. So did anybody find out what f of 1 is yet? F of 1 is, it's 12 over 6, which makes us 2. Okay. So somebody nicely did the work for you, found out what f of 1 is. Anybody find out what f of -1 is? 5 over 3? 5 over 3?
Yeah.
That sounds all right. So again, somebody else nicely put a -1 into each of these values and got 5 over 3 as our answer. So 1 goes up to 2. -1 is 5 over 3, which is almost 2. So remember, I told you it looks either like a quadratic or a chair. What does this think you? What do you think? A quadratic. So it's going to head up towards on both sides.
Okay.
Yeah, we're done.
Can you go back?
Yeah.
It's a lot of work.
That's probably why you only get one problem when you do like a test or something.